Hi, this is James Cook of the University of Maine at Augusta, and I'm shooting this video to describe 3 ways to load social network information into R, which is a research program that is really broadly useful. I'm going to assume for this video that you have installed the package igraph. If you haven't, you can Google installation of igraph on the internet, or you can join one of my courses at the University of Maine at Augusta and learn how to install igraph. But assuming that you've installed igraph, then how can you load network data in? Well, one of the easiest ways to do so is to start a script in R, which is just a series of commands that you can save, and to actually enter the data in by typing. And the easiest way to do that with a small network is by typing in an edge list. So we're going to want to start up the package that is most often used for social network analysis, not always, but most often in R, called igraph. And we'll do that with the command library igraph. And then we can say that we're going to define a network. And the use of an arrow means, hey, look at this thing we're pointing at. It's an object. It can have any name. We could give it the name Francine, and it would still work. It could be Hugo. It could be the best network ever. It should always have some kind of continuity, so don't use spaces. You could use underscores. I'm a little more humble than that, so we're not going to call it the best network ever. We'll just call it network for now. But you could give it any name. And that arrow says, yeah, that's the object. And then on the other side of the arrow is what the object is going to be equal to. Well, we're going to use the command graph parenthesis edges, and then we're going to set that equal to something. To what? A list of edges. That's what an edge list is. And in R, a list usually follows C in parenthesis. It's just one of those things. So within that, we're going to then name some nodes. And names of things should be in quotes. So we could talk about Al, and the comma says we're going to pair Al with Betty. So they're tied, and then we'll put a comma in between that pair and the next thing. Maybe Betty is tied to Clem, and maybe Clem is tied to Dot, and maybe Dot is in turn tied back to Betty. Now, when we've put that in, we can see we've put in 2 beginning parentheses, so we have to close things up with end parentheses. And so we'll put in the first end parenthesis, and then we're going to have to tell the computer, give it an option. Is this a directed network or undirected network? A directed network is one with ties that have direction. An undirected one is one without direction. Let's say these are just friendships without direction, so directed is going to be equal to false. So now we have 2 end parentheses. We've just entered a network. We can then print it on the console screen, which is on the other side of your screen. And we can also plot it with the command plot parentheses network. Again, if we named it Francine, it would be plot parentheses Francine. Let's see if I've gotten this to work by going to Edit and Run All. Sure have. I see over here on the console, down at the bottom, a list of all the ties. And over on the right, I see a list of ties between Al, Betty, Clem, and Dot. And Dot is tied back to Betty. Super! That's the easiest way to do it if you have a small network. Well, what if you have a bigger network than one with 4 ties and 4 nodes? You might be in for a bit of a hassle if you were wanting to type all that in. For one thing, let's take a look over here. The R editing screen, you notice it scrolled off toward the right as I went, right? And it's hard for us as we enter data to keep track of it all at the same time. And it's nice to be able to look. The second problem is that you could just have a typo in one place there, and boy, you'd be in trouble. So this is not necessarily the best way to go about bringing big networks in. To do that, we might want to import some CSV files. Now, CSV stands for comma separated values. It's also known as a comma delimited file. A separation or a delimiter says this is the difference between this piece of information and that piece of information, and usually there's a comma in between. That's the you could say the lingua franca of data. The CSV is this structure of data that just about any program can read, including R. Well, what can produce a CSV file? Microsoft Excel can, and by the way, so can Google Sheets if you don't own Microsoft Excel. But I'm going to use Microsoft Excel as an example here. So what could I do here? I could enter in an edge list instead. And let's make this a really common sense one. We'll start with Al and Betty. Al is tied to Betty. Let's make this bigger. There we are. And Betty to Clem, Clem to Dot. Dot likes Betty. But wait, there's more. There's also Edna, who likes Betty. Betty is very popular. People tend to be in friendships with Betty. Edna is also a friend with Fran. Fran is a friend with Gus. Gus is a friend with Howie. Howie and Inez get along, but so do Fran and Inez. And then there's Inez and Jack. Howie and Jack get along just fine. And we could just keep on going and going and going. There's Jack and, oh, why do I stop? How about Chrissy? And Chrissy and Inez are friends. And Chrissy and Leo are friends. We could just keep going on and on and on and on and on and on until we got tired of it. We could have tens of thousands of these rows. And that's the real gift about a comma delimited file. Perhaps a computer generated this for us if we were doing some kind of data mining or something like that. Well, we could just save this file as a CSV using the command file and then save as. I'm going to want to enter this in a folder somewhere. Let's put it in my R file, folder. And we're going to call it Video Network. That seems like a good idea. Now I've saved that as an Excel file, but I want to save it as a file that any program can understand. So I'll go back and I'll click here on this drop-down menu until I find comma delimited CSV. Pick that and save. Now, I've got that CSV file, or I will listen. Yeah, there we are. It says, do I want to keep using that format? Yes, I do. Microsoft Excel gets a little nervous when we move beyond its own proprietary formats, but that's okay. So we're then going to want to be able to read that in. And it's going to require a couple more pieces of commands here, but that's okay because really the benefit you get is that once you have these few commands set out anywhere, you can always copy them and paste them. You've got them to work. They'll work everywhere. They'll work for any CSV file that's in that format, the format of a comma delimited file. So let's work with that. We'll call this my data. And it's going to be, that's the object, so we're pointing at it. And what is it going to be defined as? Well, it's going to be the results of reading through a CSV, so read.csv. How are we going to read it? Well, we're going to do a choosing of a file. What that file is It's going to be in parentheses, it's blank, it's going to be up to us in the program. You're going to see it's going to pop up. And then we have to enter one more piece of information, and that is, does it have a header? In this case, I'm going to indicate false. Why? Because if you go back over here and you take a look back up at the CSV, you'll notice that there's no row at the top that says what these columns are. There doesn't have to be. It's good to know that there isn't one, so that R doesn't think that Al and Betty are somehow column headers or something like that. That's all it means. So we're going to head back over That's all it means. So we're going to head back over to R, and then we're going to take that raw information. All R knows is that it's a CSV file. You have to tell it what it means. And the way to do that is to say, hey, this isn't just a CSV file with 2 columns of data. It's a special kind of data, one that is a network. It's my network. That's the object. Again, we could call it Francine or Huckleberry Finn or whatever we want. I'll call it my network. And it's going to be equal to this. We're going to say, hey, it's a graph. And it's a data, a piece of a set of data. And it's in a frame in which we're reading my data. And it's going to be a special kind of graph. What kind of graph is it? Well, it's either going to be a directed or undirected network again. Shall we say that this is an undirected network? Sure. If it was a directed network, we would say, oh, no, it has direction. The ties have direction. True. We're going to say false for today. And then, just like before, we could print out my network, and we could also plot my network. So let's see if I have any typos in here in this approach. We'll go over and we will run this script, and we'll see what happens. Now, there should be a pop-up screen. Good. That's asking me to pick this file. So I'm going to go to my R folder, and I'm going to look for it. I think it was called video something, wasn't it? Video network. There it is. Be sure to pick the CSV file version. Video network CSV. I'll click open. And that's super. So it's now gone ahead and it has printed out the network. It has not plotted it. And I'm wondering why that is. Sometimes when R runs, it needs a little reminder to plot within igraph. So we'll give that a shot. And we'll try it again. We'll need to go to the right folder. And it hasn't done it, has it? Oh, yes, it has. Sometimes the folder, the window is underneath. Let's take a look. There's a third window under there. And there it is. It was there all the time. That's wonderful. Here's my graph. And over on the left is my set of edges. So there's an edge list there. And I've got a network. That's the second way to enter data. The third way to import data is through another kind of CSV called an adjacency matrix. And let's go back to Excel to take a look at the difference between an edge list and an adjacency matrix. So over here, we've got 2 columns, Al and Betty, Betty and Clem, Clem and Dot, Dot and Betty, Edna and Betty, and so on and so forth. And it's just listing ties that exist. But one of the things we know is that ties that don't exist are just as important as those that are. And so another form of network that you may encounter, another structure, a way of describing it, is through a matrix in which every node that's present in the network has both a row and a column, and the combination of row and column tells you whether a tie is present or not. So let's create another tab here in Microsoft Excel. And let's make that text really nice and big so that you can see it in the video. And let's go back and forth and let's reproduce the same network. Except this time we're going to take this edge list and we're going to turn it into an adjacency matrix. So there's Al and Betty and Clem and Dot, I believe it was. Who else is there? Well, there's Edna and Fran and Gus and Howie. Whoop, there's Dot. Edna and Fran and Gus and Howie. I believe there was Inez and Jack and Chrissy. Let's go back and take a look, see if my memory is correct. Yes, there's Chrissy and Leo. Can't forget Leo. So they each are going to have a column. They each will also have a row. Al and Betty and Clem and Dot and Edna and Fran and Gus and Howie, Inez, Jack, Chrissy, and Leo. Convenient, it all fits on one screen. So when we look at this edge list, we'll be able to tell who's tied to whom. Al, we know, is tied to Betty, but Al is not tied to anyone else. Nobody else is tied to Al, and we know that then, since this is a network with no direction, that the two are really one and the same. People share ties. The ties don't just go in one direction. Whoop, and there's an extra 0. We'll delete that there. In fact, we will note that most of the values in here are going to be big fat zeros. So I'm actually going to take and I'm going to cut and paste a whole bunch of zeros in to save time. Using Control-C and Control-V. And then we'll go in and we'll correct all these zeros. But we know that Al is only tied to one other person, and that's Betty. Let's go back and let's take a look at the edge list again. Betty is tied to Clem. Betty is also tied to Dot and Edna, and that's it. So Betty is tied to Clem, Dot, Edna, and of course Al, but we already covered that. Clem, Dot, and Edna. Now let's think about Clem. We already know Clem's tied to Betty, so we're going to ignore that, but we do know that Clem is tied to Dot, and that's the only other tie that Clem has got. If Clem is tied to Dot, we'll put that 1 in there. This is how an adjacency matrix works. Now let's think about Dot. Let's move that data over. We already know that Dot is tied to Betty and tied to Clem. That information is in. Anyone else? No. What about Edna then? Edna is tied to Betty. We already knew that. Edna is tied to Fran. That's new information. Let's put that in. Edna is tied to Fran, which also means Fran is tied to Edna. Gus is our next person we're going to look for ties with. Fran and Gus are tied to each other, and Gus is also tied to Howie. So Fran and Gus. And is Fran tied to anyone else? I should check. Yes, Fran is tied to Inez. And Inez is tied to Fran. So 1 means yes, a 0 means no. What about Gus? Gus is tied to Fran. We already got that. Gus is tied to Howie. And Howie is tied to Gus. What about Inez? We already know she's tied to Fran. And we already know she's tied to Howie, right? Inez has, oh, no, Inez and Howie. Inez and Howie. Good. We're almost done. What about Fran and Inez? That information is already there. Inez and Jack. Inez and Jack. Howie and Jack. Right? Howie and Jack. And then there's Jack and Chrissy. Jack and Chrissy. Two more edges to put in. Chrissy and Inez, and Chrissy and Leo. Chrissy and Inez. Inez and Chrissy. And Chrissy and Leo. So this is our network. This is the same information as is in this edge list, but it also contains information about where the ties aren't. And so it's just another form that you may encounter. We can also save this, and we'll save this particular tab, save as a CSV, and we'll call it Video Network Adjacency Matrix. In Microsoft Excel, you can only save one tab at a time to a CSV file. It may even tell me that in a pop-up message. Yes. Save only the active sheet. That's fine. It really doesn't want me to use CSV. It's got all these pop-up messages. And then we'll go back right to R. So back here at R, we're going to use the same first two lines that we used before. First, we're going to start igraph. Then we're going to take a look at my underscore data. And with an arrow, we're going to read that as CSV. We're going to choose the file. This time, header is going to equal true. Why? Because we can see some headers right up here, some column headers. Al, Betty, Clem, Dot, the names of the nodes. So in this case, header is true. And on what row are the headers? Well, they're in the first row. So we'll say that row.names equals 1. Now we're going to do a little something different. We're going to say this is not just any normal data. It's not just zeros and ones all over the place. It's a matrix. And what do we mean by it? Well, we're going to call the object myMatrix, and we're going to read it as not just zeros and ones all over the place, but as particularly a matrix, a square object with ones and zeros in it. And we're going to read it out of my data. And then furthermore, it's not just any matrix, but it's a matrix that tells us something about a network. We want this to be read as my network. And I'll call it here my network 2 to indicate that it is, or my second network. And we're going to define my second network so that we aren't just getting the same variables as before. This time we're going to be thinking about it as a form of network, which in igraph is called a graph. And it's an adjacency, matrix. Where are we going to read it from? From my matrix. And we're going to say some things about it. Here it's going to be called a mode, and it would be either directed or undirected. It's an undirected network, one without ties with directions, no directions to the ties. And we aren't going to be too worried about the diagonal. The diagonal we're not worried about, end parenthesis, false. The diagonal is the set of cells in which an individual is referring to themselves. And here they don't really mean anything if the tie is friendship, because you aren't friends with yourself, you're friends with another person. So we don't want the network to really worry too much about what's in the diagonal. So we should be able to do what we've done before. We should be able to load in my second network, to print it out by saying, hey, just tell me what it is. And we should also be able to plot it, to plot my second network. Let's see if it works. We're going to run everything. It's going to ask us to choose a file. I'll go up to my folder and we'll look for a video file. It starts with V. There's the CSV. We'll open it. And there it is. It's the same network as before. So there are two ways to read in your data. You can read it in as a CSV of an edge list. You can read it in the form of an adjacency matrix. It only takes a few lines of code, and I can use that again over and over and over again in program after program after program now that I've gotten it to work. I could use it on an adjacency matrix with 2,500 nodes in it, and it would do the same thing. That's what makes it efficient, much more efficient than simply typing in an edge list and all the possibilities and all the errors that might ensue. I hope this has been helpful to you if you're thinking about using R and the package igraph to load in social network data. Please let me know if you have any questions, and I'd be glad to help you if I can. Thanks.